Good evening, everyone. I welcome you all to the week one assignment of the mathematical method course. My name is Ujjwal Singhal. I am a PhD student. Here I have been given an opportunity to be the TA of this course. So, we will have the weekly session, like we will have session every week on Tuesday from 7 to 8 p.m. So this is the week one of the same. So this thing will continue for like 12 weeks. So basically we will have uh, 12 assignments which I will discuss. So what my plan is, so in every week assignment, I will take some question and I will try to discuss those question with you all. So here I have prepared a like a detailed solution of the some problems which I think are relevant. So, uh, and also I urge you all to basically practice all these problem by your own, so that you can become more comfortable on solving the problem. Okay, I will start. So basically, this is the week one mathematical method course, and in this week one tutorial, I will discuss like 10 problems from this assignment with their detailed solution. So, okay, let's start. So this is the first problem for the week one assignment. So what I will do, I will first discuss like what is the question trying to say, and what how you can solve this problem, right? So basically the problem here is like you need to find a order and the degree of differential equation of all the circles which have radius r and their centers lie on the y-axis and they passing through the origin. So basically what you need to do in this question, first you need to write the equation of a circle which is having center on y-axis and it passes through the origin, right? So here is the solution of this problem. So basically what you do, so just let me like just laser pointer. So here is the solution of the problem. So first what you do, you basically just write the equation of the circle which has a radius r and its center lie on the y-axis. So basically what you have x square plus y minus r ka whole square is equal to r square. So this is the equation of a circle that passes through the origin and its center lie on the y-axis. So from this equation, what you can do, you can expand this equation and you can write like x square plus y square minus 2yr is equal to 0. Now you see in this equation, you have only one variable which is the radius of the circle. So what you can do, you can find the expression of r from this equation and you can write r as x square plus y square upon 2y, right? So basically now you have expressed the radius r of this circle in terms of x and y. Now what you do, you basically differentiate this equation which I am highlighting with respect to x. So basically when you differentiate it with respect to x, you get differentiation of x square is 2x, and then the differentiation of y square will be 2y dash, where y is a dependent variable, and then you have minus 2r y dash is equal to 0, right? Because the derivative of y will be dy by dx. So now what you can do, you can take the 2 common out of this equation, and what you are left with, x plus y dash times y minus r is equal to 0, where I have taken the y dash out of this by taking common uh, variable y dash out of this equation, and I can write my equation like this, right? Now what you can do, you can again put the value of r from above, like you computed r, which is r is equal to x square plus y square upon 2y, and then you again substitute back in this equation. Now if you again solve this equation, you get 2xy plus y dash times y square minus x square is equal to 0. So now this is the differential equation of all the circles which have radius r and their center lie on the y-axis and they passes through the origin, right? So now you can easily find like what are the order and degree of this differential equation. So basically the equation have only single derivative which is y dash, so its order is 1, and the power to which this derivative is raised is equal to 1. Therefore, the both order and degree of this differential equation is equal to 1. So therefore, the answer of this problem 1 is the order of this uh, differential equation is 1, and also the degree of this differential equation is equal to 1. So I hope you all got the idea like what to do in these questions, and I think it's a very straightforward question. Okay, so this is all about this first question. Okay, now let's move to second question. So here is the second question. So uh, what you have, you are given some set of four differential equations, and among them you need to find like which differential equation is non-linear, right? So I hope you have all during your lectures have read like what are linear as well as non-linear differential equation. So just here for the recap, so basically different linear equation are those in which the derivative, like the dependent parameter, here the dependent parameter is y because it has derivative with respect to x. So basically if you have all the derivatives uh, in the differential equation, if they appears in a linear fashion, and there is no higher power, like there is no square or cubic term of the dependent variable, then that equation is a linear differential equation. And also it should not have any product terms like y dash, like those terms. So basically if I start with the first term, I see like this is a linear differential equation, right? Again, let me just use the laser pointer. So basically first equation is the linear differential equation because all derivative appears in a linear fashion, and also the dependent parameter is a linear. It has only power 1, right? So this is a linear differential equation. Now coming back to B problem, B part. Again you see all the derivatives and the dependent variable are appearing in the linear fashion. So again this is a linear differential equation. Now coming back to the third problem, you have triple derivative, second derivative, y derivative, single derivative, and till here it's a linear differential equation. But if you see now, this equation has a power of y square, and if you have like some square or cubic term of the dependent variable, then the differential equation itself is a non-linear differential equation. So basically, in the second problem, the option C is correct because this is a non-linear differential equation. And again, if I come back to the fourth part, which is y double dash is equal to y dash plus tan of root x, then again the derivative all appeared in the linear fashion. Again, it's a linear differential equation. Okay. So basically, the answer to this problem, second problem uh, is like option C is correct because it's a non-linear differential equation. Okay. So this is the all about the second problem, and I hope you got the idea. Like if you get such problem in your exams or in assignment, you will be able to now solve. Okay. Now I will give you another flavor of the problem. So I will move to question number 3. So basically, here is the question number 3, and what this question number 3 is asking you, like you are given a like a set of three functions. In basically option A has three functions, again option B has three functions, and same goes for C and D. And you are asked like yeah, if you have these following pairs of function, and you need to find like whether these functions are linearly dependent on interval 0 to infinity, right? Uh, okay, so I hope you all know like how to solve this problem. So the main idea behind this problem is to just you need to solve the Roskin, like you need to write the determinant of the Roskin, and if that determinant is 0, then these functions all are linearly dependent, and if this Roskin determinant of the Roskin is not equal to 0, then basically those functions are linearly independent. So here among all four, only only one option is correct. So basically all other three are linearly independent, so only one option is correct, which leads to a linearly dependent solution. So here I will give the solution. So what I have done, I know like B is the correct answer, so I have taken the option B and I tried to find the Roskin of the same. So basically what you do, you write the Roskin of these functions. So now how to write the Roskin? So what you do, you have a 3 by 3 matrix because you have three functions, and what you do, you first just write the function values, like you have e power x function, e power minus x function, and the cos hyperbolic x function, right? Yeah, as you are given, because you have e power x, e power minus x, and cos hyperbolic x, right? Now what you do, in the first row you just write the functions. Now in the second row, what you need to do, you need to take the first derivative of the above function. So basically, if I take the derivative of the first function, e power x, then the derivative of exponential is itself exponential, so I have e power x only. But if I take the derivative of e power minus x, then I will get one minus sign outside of this function, and I will get minus e power minus x, right? And now the you again do the first derivative of the cos hyperbolic function, and you get the sine hyperbolic x, right? And now, so in the second row, you just need to write the first derivative of the above functions. Now again in the third row, sorry, you need to just write the second derivative of the above function, which is in the first row. So basically, if you differentiate e power x twice, you will get the e power x. And now like the second column, if you differentiate e power minus x twice, then you will get again e power minus x, because minus sign will come twice and it will turn to positive sign. And again, if you do the different double differentiation of cos hyperbolic x, you again get the cos hyperbolic x. So now, if now one can easily calculate like what will be the determinant of the matrix. So here I just calculated the determinant of this matrix, and I get the determinant of this Roskin is equal to 0, right? So basically, when you have the determinant of the Roskin is equal to 0, then you say basically these all pair of functions are linearly dependent on each other, right? So basically option B is correct. So although I have not solved the A, C, D part, so I urge you all to do the same with the option A, C, and D. And what you will get in this case, you will just get non-zero determinant of the Roskin. So basically option A, option C, and option D, all the pairs of function in these options are linearly independent on interval 0 to infinity. So I hope you got the idea like how to solve such type of problems where the question demands like if you need to find the linearly dependent functions, right? Okay, so this is all about the third problem. So I will again go back again move forward, and I will move to question number 4. So I have again taken the question number 4 as same type of problem as question number 3. So again you are giving a four set of functions, like you have option 1, option 2, option 3, and option 4, and you again have some three function in them, and they are defined in different intervals, right? So now you are again given four options, and you need to find like whether like among all four, two are linearly dependent and two other are not linearly independent. So you just need to again calculate the Roskin of all the four options, and then you just see like whether one and two are linearly dependent or some other options are linearly dependent. Okay. So what I will do again, I will go to the to the solution of this question number 4. So what I have taken here, I have taken the option 1, like if you take Roskin of the function minus 2 cos x sin x, then again as I told you, just write the function values here like minus 2 cos x sin x. And then in the second row, what you do, you just take the derivative of the above function. So derivative, first order derivative of the constant is 0, and the derivative of cos x is minus sin x, and the derivative of sin x is equal to cos x, right? And in the third row, you again do the second order derivative. So what you have again the derivative of 0 is 0. And then if you do the differentiation of cos x twice, you will end up with minus cos x, right? And here, if you do the derivative of sin x double derivative, you end up with minus sin x. And again, if I solve the determinant of this problem, this matrix, I get minus 2. So basically, this determinant of this Roskin is not equal to 0. Therefore, the option 1, the functions given in option 1 are linearly independent. Okay. So again, let's do the same for the option B. So what you have here, you have three functions, polynomial function x square and x plus 3x square, right? You can see here option B has x square and x plus 3x square, right? So what you do in this case, you again take the first derivative. So first derivative of x is 1. Again the derivative of x square is 2x, and here you will get 1 plus 6x, right? Because the x square power of x square will come in front 3 and it will get 6. And again you do the second derivative. So basically again the derivative of 1 is 0, and derivative of 2x with respect to x is 2, and again here you will get derivative of 1 plus 6 is equal to 6, right? So again if I try to solve the determinant of this, right, if I try to solve the determinant of this matrix, I get 0. So basically that is saying like all these three functions given in option B are linearly dependent on each other. Okay, so I guess this is a very straightforward problem. Now if you get these type of problem, you will be able to solve them, right? So just for the completeness, let me do it for the third option also, and I will urge you all to do it for the option number 4, right? And then choose the correct answer by yourself. So here again you are given the three functions. You have e power x, e power 2x, and e power 3x. So again what you do, you again take the right, just write the function e power x, e power 2x in e power 3x. And what you have now, if you take the first derivative of e power x, you have e power x. The first derivative of e power 2x is 2e2x, and the first derivative of e power 3x is 3e3x, right? And then again you do the same business by taking the second derivative. So you have e power x, and then you have 4e2x, and then you have 9e power 3x. So again if you try to find the determinant of this matrix, you will get the non-zero determinant. So therefore the functions which are given in option 3 are all linearly independent. Okay, so basically among option 1 2 3, only second option is linearly dependent, right? So basically I just tell you like what is the answer. So answer of this option is D. So I will urge you all to try the option 4 by yourself. Like you try to calculate the Roskin of this and see what you get. So you will get, in the end you will get the determinant of the Roskin of these function will be 0. So basically these all are linearly dependent. Okay. So this is all about the question number 4. Now let me just move to question number 5, right? So in question number 3 and 4, although they are same type of problem, but I include them so that you don't have any problem in doing these type of problem. So let me move to question number 5, right? So here this is a number type problem where you need to construct first the differential equation, and then you need to put a boundary condition to find the variable in your differential equation, and then the question demands you some answers from it. So let's go through the problem. So the question is such that the rate at which bacteria multiply is proportional to the instantaneous number present. So you have some bacteria, right? So there can be some n number of bacteria, and the question is saying that rate at which this bacteria is multiplying is proportional to the instantaneous number itself, right? So basically the rate which is equal to dn by dt, right? Because the rate of change of bacteria with time is equal to dn by dt. And then so let's just go through the answer. So what you have some n number of bacteria at any time t, right? And then the question is saying the rate of the change, number of change in this bacteria is proportional to the number itself. So here what I have done, I have replaced the proportionality constant by some value k. So basically you have dn by dt is equal to km, right? And then now what you can do, you can take this n in the denominator of dn. So basically you have dn by n is equal to k times dt, right? Now I think it's a simple integration you can do. So basically if you differentiate on the left hand side, you will get ln n, and then here you will get kt, and by solving this what you get n is equal to c times e power kt, right? Where c is coming from the integration. So here you have c and k both are constant. So k is proportionality constant and c is the constant that is coming due to integration of this equation, right? Yeah. So now you have the expression of number of bacteria with time, right? So now suppose at t is equal to 0, right? At some, like, from where you are starting, that I am defining at t is equal to 0, and you have some n naught number of bacteria. So basically at t is equal to 0 you have n naught bacteria. So now if you substitute this uh, thing in this equation, what you get, you can easily calculate the value of c, right? Because the e power 0 will be 1, so the value of c will be just equal to the number of bacteria that are present at t is equal to 0, right? Now what you can do, again in the equation you are giving that if the original number doubles in 2 hours, so basically at some t is equal to 2 hours, you have enhancement in the number of bacteria. So basically these number is getting double. So basically at t is equal to 2 hours, your instantaneous number of bacteria will equal to 2 times n naught, because n naught is the bacteria at t is equal to 0. So now from here what you can do, you already have the value of c, right, which you computed by using this boundary condition. And then from here, from the second boundary condition, what you can do, you can just put these values in this equation, and then you can calculate what will be the value of the proportionality constant, right? So if I put t is equal to 2 in this equation and n is equal to 2 times n naught with c is equal to n naught, what I get? I get value of k is equal to ln 2 by 2. So basically now you have the value of both the variables that are present in your equation. So basically now you have just the expression of n in terms of t, and you have already find the value of both the constants in this equation. Now what question is asking, right? So question is asking like in how many hours it will get triple. So basically the question is saying like if you have now 3 times bacteria, right, from where you started. So basically the instantaneous number of bacteria will be 3 n naught, right here. So if I do this, if I write 3 n naught is equal to n naught times e power kt, where k is ln 2 by 2, I can just simply calculate like what will be the value of time t when this number is getting triple, right? So from here I can just easily calculate like what will be the time t. So time t it takes to get the number triple is equal to 2 ln 3 by ln 2. So in this equation you can see option C is correct, because this is the time after which your bacteria will get triple. So I hope this equation is also, this question is also straightforward, and uh, uh, I hope you will also try it by yourself, right? So again I will move to question number 6. So again question number 6 is like a same type of problem as question number 5. It's just the equation you are constructing is different. So in question number 5 you are getting the rate is getting double, right? So you have the positive rate, yeah, dn by dt in the last problem is positive. But here what problem is saying, so let's go through the problem. So if you have some radioactive substance, right, you have some radioactive substance, and question is saying if 20% of the radioactive substance disappears in 10 days. So you have some radioactive substance, and that 20% of the radioactive substance is getting disappear is in 10 days, then how many number of days it will take for the 80% it to disappear? Okay, I hope like you guys can solve this problem because it's mostly same as the problem number 5, but just for the completeness I will go through the solution of this question. So what you have, suppose you have some radioactive substance which has some mass m, right? So you have some mass m of the radioactive substance. So what you can do, you can again write the same differential equation. So basically you have dm by dt, like the rate of change of mass is again proportional to the mass itself, and here I have put the proportionality constant as mu. And the fact that the this mass is decreasing with time, you will have the minus sign. As in the last problem, as the rate was increasing, so there you have positive sign. And the fact that the number here is getting decrease, the mass is getting decrease, you will have the negative sign. Okay, then again you can bring this m here in the denominator of dm. So you basically have dm by m is equal to minus mu dt, and again you can integrate on both the side to get this type of solution. You have ln m is equal to minus mu t plus c. Now again you do the same business as you did for the fifth problem, right? Uh, so again at t is equal to 0, suppose you have some mass which is equal to m naught, right? So from here at t is equal to 0, if you put like sorry, just sorry for this, yeah. So if you what you can do now, you can again like at t is equal to 0, you have some mass which is m naught, right? And then if you put t is equal to 0 in this, you can again calculate the integration constant c value, which is equal to ln m naught, where m naught is the mass which is present at t is equal to 0. And from here, what you can do, you can calculate like what will be the value of m, like by putting again in this equation, you can get like what will be the value of m as a function of t. So basically m is equal to m naught times e power minus mu t, right? Where mu is the proportionality constant, right? Now again, in this problem you are giving like if 20% of the radioactive substance disappears, so if you have some mass m naught and 20% of the mass is getting disappeared, so what you left with, you will left with just 80% mass. So basically m will be 0.8 m naught and t is equal to 10 days, right? So again you put this boundary condition in this problem, so in this equation, so you have 0.8 times m naught is equal to m naught times e power minus mu times 10, because t is 10. And from here you can compute like what is the value of mu, which is the proportionality constant. So basically mu comes out 1 by 10 ln 10 by 8, right? Now you can completely express your mass in terms of initial mass as well as time, right? So you have this type of expression of m with respect to time t. Now what question is asking, right? So question is asking like how much days it will take for the mass to get 80 so that 80% of it to get will get disappear. So basically if 80% of the mass will get disappear, so what you are left with, you are just left with the 20% of the mass. So 20% of the mass, initial mass is 0.2 m naught. So basically you have m is equal to 0.2 m naught, and then you need to calculate like what is the time corresponding to this mass. So you just substitute this m is equal to 0.2 m naught, and then m naught cancel both sides, and then from here you can just directly calculate like what will be the value of time t, so that 80% of the mass will get disappear. So from here if I see, so 10 ln 5 by minus ln 4, so option B is correct. So for question number 6, option B is the correct answer. So again, I tried to like give you a different flavor of these, some type of subjective equations where you need to construct the differential equation according to the given problem. And here, although question number 5 and 6 are nearly same, but I just kept them so that uh, uh, you can have more practice on that. So okay, this is all about the problem number 6. So what I do, I will move back to uh, problem number 7, right? So just let me again bring my laser pointer. So now I will again give you a flavor of some different problem. So here what I have done, I have taken some differential equation, and what you need to do, you need to find the general solution of this differential equation, right? So I hope in class you have gone through the this homogeneous second order differential equation. So basically this derivative is of second derivative, so its order is 2, and the fact that the right hand side of this differential equation has is 0, so basically you call this homogeneous second order homogeneous differential equation. And what you do in basically solving this problem, you basically just try to find like what is the auxiliary equation of this differential equation, right? I hope you have gone through this in your class where you have calculated the auxiliary equation for the second order homogeneous differential equation, right? So here I will start with the problem, although I suppose you already know like what is the answer. So just let me go through it. So basically it is a second order homogeneous differential equation. So what you write, you first just basically write the auxiliary equation of this second order homogeneous differential equation. So basically you have this am square plus bm plus c is equal to 0, where a is the coefficient of the second derivative and b is the coefficient of the first order derivative, and the constant c is the coefficient of the dependent variable, right? So basically you have a is equal to 1, b is equal to -6, and c is equal to 9. And from here, if you try to like now solve this quadratic equation, you will get two roots because it's a quadratic equation. And from here, what you get two equal and real roots. So basically you get m is equal to 3 and 3. And now I hope like you already know like how to write the general solution if you have both equal and real roots. So in that case, the solution is y is equal to e power times mx, where m is 3, and then you have c1 plus c2x, right? Where x is the independent variable. So I hope you will be able to solve such type of problem. And just for the completeness, I just want to mention here. So suppose you have some differential equation, differential equation, and by solving the auxiliary equation, if you get value of m which is equal like 3 and minus 1, right? Suppose you got some value which are m is equal to 3 and m is equal to minus 1, right? So what you can do now, you have both distinct and real roots, right? uh, Unlike here where the roots are real and equal, you will have the real and distinct roots. So in that case the solution is e power m1x times c1 plus e power m2x times c2. So there you don't have this x term, you just have the exponential terms with both of the constant c1 and c2. Okay, so I just want to mention here, like if you get the problem where you have real and distinct root, so in that case the solution will be different. So okay, so the only one option is correct among them. So I hope option A is correct because the value of m you get is 3. And here you can see you have the option of uh, other option doesn't match actually, so option 1 is correct. So I hope you got the flavor like how to solve like second order homogeneous differential equation in case of distinct root as well as in case of equal roots. So okay, this is all about the uh, uh, solution of problem number 7. So I will move forward and I will move to uh, uh, question number 8. So again, what I have done, I have again taken the same type of problem, but it's little different. So I have given you the idea of like if you have real roots, real and equal roots, and if you have real and distinct roots, right? So how to write the solution in that case. Here, what I have taken a different problem. So let's go through the problem. So you again have the second order homogeneous differential equation, right? So here you have d square x by dy square plus 2 dx by dy plus 2x, right? And please see like here you don't have d square y by dx square. Here x is the dependent variable, not y, as compared to earlier problem. So here again the question is asking you to write the general solution of this differential equation, right? So okay, let's go through the solution of this problem. So you have this differential equation, and again what you do, you write the auxiliary equation of this differential equation. So basically again you have m square plus 2m plus 2 ka whole square, because you have whole square is equal to, you have whole square here in the given differential equation. So here you see now this is a biquadratic equation, so it will have four roots, right? As this is biquadratic, and the coefficient here are coming like because the coefficient of second derivative is 1, so you have coefficient in front of m square is 1. You have the coefficient of the single derivative is equal to 2, so you have 2 appearing here, and the coefficient in front of the dependent variable is 2. So basically you have this equation to solve. Now if you try to find the value of m which satisfies this biquadratic equation, you will get this type of two equal roots. And so you have two roots which are equal and they are also complex conjugate of each other, right? So basically you have -1 plus minus iota and again -1 plus minus iota. And I hope like now you have, see, you have two equal roots, so basically you will get you will have to put the function like some c1 plus c2y, right, as I told you, because if you have some equal roots, then you need to have c1 plus c2y type of function. Why? Because the differential equation, in this given differential equation, the dependent variable is y, not x. Okay, and the fact that these two root are having are complex conjugate of each other, and I hope you in class you have gone through the lectures, and there if you have the complex root, then the general solution comes in terms of cos y and sin y, right? So the final solution appears like this, where I have taken the e power minus y common, and then I have written the general solution in terms of cos y and sin y. Cos y and sin y are appearing because you get two complex conjugate root. So I hope now I have given you the flavor of all the three types of problem that comes under the second order homogeneous differential equation, and I hope you can all now able to solve such type of problem. So just going here, so you can see only one option satisfy this. So you have option B is correct because you have e power minus y and then c1 plus y c2 cos y plus c3 plus y c4 times sin y. So again, I hope you understood like how to solve this problem, and again I will urge you all to please practice like whatever I have discussed, so that you can get more understanding on how to solve the problem, and also like the more you practice, the more you will get from the subject, right? So here I will move to the ninth question. So here again I tried to give you the some other flavor of the type of problem. So here what I have, now I have taken the non-homogeneous differential equation. So again you have this y double dash plus 3y dash plus 2y is equal to 2x square plus 3 power minus x. The fact that the double derivative appears in problem, this is a second order differential equation, and the fact that now the right hand side is not equal to 0, you will have the non-homogeneous, you called it non-homogeneous differential equation, right? Sorry, I have to check in between like whether recording is going on or not, so sorry for this. So here what you need to do, you just need to find the particular integral of this differential equation, right? So the one of the way to solve such type of problem is basically you first guess some solution of this second order non-homogeneous differential equation, which is also called method of undetermined coefficient. So basically you guess some solution, and then what you do, you just try to satisfy this the guess solution by putting your solution in the given differential equation, right? So here, just to mention, the question is not asking you to find the general solution. It is just asking you to find the particular integral of this non-homogeneous second order differential equation. So again, like I just want to give you the flavor of like how to solve this problem. So here, what you do, first just for the practice, what you do, you just solve the the homogeneous differential equation part. So again, as I did earlier, we just again calculate what is the auxiliary equation of just the homogeneous part of this differential equation. So basically you have m square plus 3m plus 2 is equal to 0, and from there if you try to calculate like what are the roots of this equation, you will get m is equal to minus 1 and m is equal to minus 2. So basically the both of the roots of this homogeneous equation are real and distinct, and we know if you have a real and distinct roots, then the solution is basically y is equal to e power minus x times c1 plus e power minus 2x times c2, right, as I told you before. Now you see your solution already have exponential part, right? Now let's move to the non-homogeneous part. So you see now, you see if you see non-homogeneous part, you have 2x square plus 3 minus x. So now you can guess like what will be the particular solution of this non-homogeneous part. So basically if you have 2x square, then you will think like I will have a solution of like c1x square plus c2x plus c3. That is just coming because you have this x square in the non-homogeneous part of the differential equation, and now you need to guess like what will be the solution if I have e power minus x in this differential equation. Now you can say, like, if I have e power minus x, then I can just put c4 e power minus x in this differential equation. But let me tell you, so you already have the uh, e power minus x by solving the homogeneous differential equation part. Okay, and now if you just take the c4 e minus x and you try to satisfy this solution by putting into the differential equation, you will end up like your coefficients, you will get some four equation, but that from that four equation you will see that they are not giving you any result. So what you do, then you need to move forward and you think like what should be the other solution. So what you do, if you try this type of solution where you have c power 4 x e minus x, then you see that this equation, this solution, trial solution, which is particular integral of this non-homogeneous differential equation, is satisfy this problem. So I will urge you all to just take this solution, trial solution, and just try to put it in this differential equation, and from there you can easily calculate like what are the values of c1, c2, c3 and c4. And again, you should try like taking the solution like without x. Just take c1 x square plus c2 x plus c3 plus c4 times e power minus x. In that case, what you see, you will not able to solve the value of these constant. So I hope you will all go through this problem for your own self understanding, so that it's, if you get such type of problem in future, you can just directly guess like what will be the trial solution of this non-homogeneous differential equation. Okay, so here if I go here, so I see only option D is correct, but you see here the option B is also given, right? So I will urge you all to put this option B in this given differential equation and see if you can calculate like what will be the value of C1, C2, C3 and C4. Okay, so I hope you all will try this problem because I think this is an important problem. Okay, so okay, then what I will do, I will move to last problem of this tutorial number one. Okay, so again in the 10th problem, what I have done, I have again taken like the same non-homogeneous differential equation of second order. So here you see what question is asking. Now question is asking you to find the general solution of the differential equation, right? So it's not asking you to just find the particular solution of the non-homogeneous differential equation, but it's asking you to find the general solution. Now in this case, what one do is basically, what you do, you first just solve the homogeneous part of the differential equation. Basically you calculate the solution corresponding to the homogeneous part, and then what you do, you guess some particular integral of the equation. So basically, as you did earlier, you will guess some solution, and then what you do, you try to put this solution back in this differential equation, and from there you can get the your final particular solution, which will not have any constant, right? And then the general solution of this equation is a combination of both solution that are coming from the homogeneous part as well as the non-homogeneous part. So here I will just try to give you like how to solve this problem. So as I told you, first you just need to calculate the auxiliary equation part, right? So you have m square plus 2m is equal to 0 because there is no constant coefficient here. So you have just m square plus 2m is equal to 0. So here you have again, you have two real and distinct roots, right? Uh, so as I told you, if you have real and distinct root, the solution of auxiliary equation will be y is equal to c1 times e power 0 plus c2 times e power minus 2x, and the fact that m is equal to 0, the exponential term will give rise to a value of 1, so you just have c1 plus c2 times e power minus 2x. Now the difficult part comes. Now you need to guess like what is the particular solution. So here if you have like e power x sin x, so the most common guess solution of these type of differential equation, you just take this type of guess solution. You take the combination of cos as well as sin. So suppose if you are given in the question like cos x, like e power x cos x, then in that case also you will take the same guess solution, and from there what you do now, you first, as I told you, first take this particular solution and you try to satisfy this given differential equation. So in order to satisfy this given differential equation, I need to have like what will be the value of second derivative, as well as I need to have like what will be the value of first derivative of the given particular solution. So if I take the second derivative, first derivative of this, so I will get e power x, and then the derivative of cos x will be minus a sin x, and then I will have the derivative of b sin x will be cos x. And the fact that there is a product of e power x and cos x, then you need to differentiate it twice. I hope you know it all. So basically in the first case I have kept this first part as constant and I have taken the derivative of second part, and in the second part I have taken this second term as a whole like constant, and I have taken the derivative of first. Okay, then again you do the same business of this by doing the second derivative, because you need to put the second derivative and the first derivative in the problem in order to satisfy the differential equation. So here again you can do the second derivative, which I guess it's easy because now you have four terms, two corresponding to this and two corresponding to this. And now if you try to simplify like what will be the value of my second derivative, you will get this type of solution. So double derivative is 2 ex times minus a sin x plus b cos x, right? Now you have the value of first derivative, you have the value of second derivative. So what you can do, you can put them all together in the given differential equation, right? So you can put the value of d square y by dx square, you can put the value of dy by dx, right? And from there what you can do now, you can put this all equation in the given differential equation, and now you see you will end up with this type of equation, right? So now the our aim is to calculate like what are the value of a and b's, because here you have only two constant, right, a and b. So basically you will get two equations by solving this equation, and from there you can compute like what will be the value of a and what will be the value of b. So what you do now, so you see you have e power x sin x term, e power x cos x terms, right? So if you just see this equation complete, you only have terms which are e power x sin x and e power x cos x, right? So now what you can do, you can compare the coefficient of e power x sin x and e power x cos x on both left hand side and right hand side. So if you see on the right hand side, there is no term that term of e power x cos x. So basically if I just take the coefficient of e power x sin x, so e power x sin x coefficient here is minus 2a, then again the same term is appearing, so total it's become minus 4a, and then you have this term, so minus 4a plus 2b is equal to 1, because the coefficient of e power x sin x on the right hand side is 1. And now you do the same business for the cos x. So if you take the cos x part, e power x cos x part, you have 2b, and then you have one more 2b, so total is 4b e power x cos x, and then you have 2a. So basically 4b plus 2a is equal to 0, because there is no term on the right hand side of e power x cos x type. So basically now you have two equation, two variable, you can easily solve like what will be the value of b and what will be the value of a. So value of b will be 1 by 10 and value of a will be minus 2 by 10, right? So from here you can easily now express like what will be the particular integral or the guess solution of the non-homogeneous differential equation. So basically you started with this, right, e power x a cos x plus b sin x. You can just put the value of a and b and you can get this particular solution. As I told you, now the question is asking the like what is the general solution of this differential equation, right? So to find that, what you do, you take the, because this is also some solution of the differential equation, and the earlier this one is also the some solution to the differential equation. So what you do, the general solution is a combination of both of these solutions. So basically you have y is equal to c1 plus c2 times e power minus 2x, that is coming by solving the homogeneous part, and then you have this solution which is coming by solving the non-homogeneous part. So basically the complete general solution of this differential equation can be written in this form. So if I now so basically this is the answer to this problem, and just for the completeness I want to mention, suppose you took some guess solution of the non-homogeneous part and you try to satisfy this. So if your trial solution is wrong, then you will not be able to solve the values of coefficient like a and b. So only when you are trying the right solution, there only you will get the value of a and b. Like you will get some solution, some equation among them variable which is solvable. So I hope I tried to cover like most of the things which you have covered in class in this tutorial one. So again, in the end, I would like to say like you should all try to solve these all 10 problem by your own. And in the second tutorial, you can let me know if you have any doubt among all these tutorial, among the first tutorial. And from the second tutorial, what I will do, I will try to cover more questions, right? So here I have covered only 10 questions. From next time, what I will do, I will try to cover maybe 12 question or 13 or 15 question depending on the time, and so that you can get more practice and you can get the more feel of the problems. Okay, so this is all about the week 1 assignment problem, and I hope I was clear enough so that you got a good idea of how to solve such problems. So I thank you all for your attention, and this is what I have from my side in the first tutorial. So I will again meet you guys in the second session on Tuesday 7 to 8 p.m. Okay then, see you all, have a good evening.